I'm an emergency manager. I specialize in disaster response. You may have seen this news story going around about the house that was unaffected by the LA wildfires and then was split in two by a landslide. Let's talk about that. So, first of all, the coast of California, like any coastal region, is susceptible to erosion, which increases the chance of landslides occurring. There's big slopes, there's cliffs, you're near a huge body of water, and that increases the chances of erosion. Preventing erosion is incredibly difficult. So stopping erosion, stopping cliff sides from eventually collapsing, and stopping landslides, very hard to do. Now, in the case of fire moving through, that even further increases the chances of landslides. So everybody that's saying about the LA wildfires, we just need rain, we need a lot of rain. At this point, rain is going to be very detrimental. Like the first big rains that now come through these fire affected areas in LA it's going to be tough, and it can cause additional disasters. And this is a really good article in the Atlantic that covers why and what could happen. This muddy water picture you see below is what a landslide can look like after a fire and when a landslide has ripped through a fire burn scar or a fire affected area. Essentially what happens is when you have fire that categorically speaking is moderate to severe, that's how the measurements go. And in the case of the LA wildfires, this was personally, I would categorize it as severe fire. I was not there. I was not fighting the fire. So that is a personal guess, not a fact. But when fire, in the case of moderate to severe fire, rips through an area, it eats up everything that is organic in the area, everything that's flammable in the area, right? Well, in the case of slopes, it eats up brush, trees, anything organic in that ground. So when we're talking about the slopes surrounding these areas, all that wildfire that was running up those hills and those mountains, it has killed everything or has burnt the living organic matter to the point that it will die. And what happens, the root systems then go. If the root systems weren't already burnt by the fire, the plant has died, the roots will die. And roots within soil they're kind of like a structure, right? It's a web-like structure that helps hold that soil together or that earth together. It's like a mesh net, if you think about it. The best way I've read it as described is it increases the mechanical strength of the ground. But to have roots in there that run deep, they run into each other, it increases that strength so it can't just be brushed away, right? Well, when everything has been cleared out, the root system underground, so the skeleton has been burnt out or died or turned to ash, and then everything living above that tethered has died and has disappeared as well. That land is very susceptible to landslides. There's nothing standing in the way of the rocks getting stuck on something or preventing them from coming down. There's nothing protecting that land. It's just now burnt into dusty duff that is easily carried away by water. So in this article in the Atlantic, they cover the fact that a ton of water suddenly coming in is a really serious problem. And a ton of water is really just a big rainstorm for this area. And this is twofold, right? Because this is already an erosion-prone landscape, and it is now a burn scar. So it has now been severely damaged as far as the ground goes. So what do they do about it? I got a question about like this on an earlier video of like, how do you prevent this from happening? And here is a really good quote I'm going to read. You can't see the top of this because TikTok's cutting it off, but this is the author has spoken to Jason Keene, who is a research hydrologist with the U.S. Geological Survey landslide hazard team. So he's an expert in this stuff. This is the guy I want to learn from on this stuff. And basically they say the first step is comparing infrared satellite images of greater Los Angeles taken before and after the fires to map the most badly burnt parts of the landscape. Most concerning are moderate or severe burns like I was talking about. Analysts plug data in on burn severity, slope pitch, and soil composition into computer models that show how those areas are likely to react to rainstorms of different strengths. So this is really fascinating because we're using computer modeling, which we use on a lot of other disasters as far as like what could happen for humans to understand what could happen, especially when we're in the planning phases. We use computer modeling. We use this on volcanoes. And so on landslides, they are collecting this data at a rapid rate right now because they are worried about this happening. So there are scientists out in the field and using equipment to take in as much data as possible, because as you saw when I started this video, a house is already split in two, a landslide has already happened. And I bring this up because I've heard a lot of commentary from bystanders about like, well, we just need rain, or, you know, they need to let those people back in, or, you know, well, now it won't burn again. No, it is complex. This is what is going to happen is complex. This is not black and white. This is not simple. A disaster of this magnitude, of this complexity, to happen in a region like this that is already at risk of other things. This is also a major earthquake risk area. This is also a tsunami zone. The west coast of the United States is a very high risk area. Any coastal region is, but especially the United States coasts. That's just the reality of it, geographically and geologically. I would recommend you go read this article and do research if you are curious about this topic or understanding more about it. They are already taking action. They're sandbagging. They're out there trying to prevent this from happening. And as I said, they're doing research. This is in the Atlantic specifically, but there are more resources as far as understanding landslides. U.S. Geological Survey, they have a website that's fantastic to learn about landslides, soil composition, how it's affected. You can learn more about the software that they're talking about in the article as well. And they're a really fascinating agency as far as the research that they do around hazards. I've worked with some of their folks before, and yeah, they are smart people.